Welcome to current 2025. Okay, so today we're going to talk about very interesting thing for me. Hopefully it would be also very interesting thing for you. I am very interested in schemas in general, and this is kind of like a one-on-one talk. So if you're already using Schema Registry and you enjoy using Schema Registry, you might pick up some interesting, funny jokes here, but not much. But if you're not, and you're still on the fence and you're considering to using this stuff, so the talk is exists to convince you that you should at least consider, and at most, start using it today. So, in the very golden days of Kafka, you deploy your Kafka into whatever. You can use the Linux, containers, Kubernetes, you're running in managed service, whatever. And in this world, you have system where everything speaks same language. Say you're Java shop, and Kafka is written in Java, using producer and consumer, or maybe if you fancy, you're using a Kafka streams for dealing with this stuff with stream processing, and everything's good. Your applications, they know how to speak this the cool thing that we have in Java called Java serialization, which is not, it's kind of like a pun. But whenever they speak same language, same programming language, there's no problem with the data. However, when we get this new race of developers invading our Java world, we need to start thinking about the polyglot systems and how we can deal with the multi-language setup. Specifically, you running microservices. We were at this stage, or from the other places in Austin and maybe in Bangalore or in London, would tell you about the microservices for the last, 3-4 years. That is cool, and for Kafka it would be great. And the polyglot would be a bigger aspect. It's because the microservices, the selling point of microservices was giving you ability to have a control over, what kind of language you used to develop. And now everyone is doing Java, and these microservices that written in Go need to somehow coexist. But is in the very beginning of everything, when the thing starts with this conversation, people try to consume the messages that are already available in Kafka, and they serialized with Java. And we start seeing this biblical story of Tower of Babel, where the different systems, different developers of microservices start speaking different languages, and they couldn't agree about the message format. So the chaos erupted, and the conversation started like, what do we need to do? But as always, don't be despair. There's a hope. And we're going to talk about this stuff today. My name is Victor Gamov, and I'm here to present you a very interesting conversation from the Tower of Babel to Babel Fish. Any Hitchhiker Guide for Galaxy fans who spot the pun on the Babel? No? Anyone? Babel Fish? I'll explain. Even though if you didn't read or didn't familiar with this. I work as a principal developer advocate at Confluent. I build stuff, I break stuff most of the time. I talk to developers. I like to also listen from developers and learning whatever they're doing. And after that, maybe you'll get inspiration for my own demos. Wrote the book for Manning about Kafka called Kafka in Action. And I also Java champion, but I really like to talk to people in a different languages. So this demo and my presentation will include some of the bits that only Java, even though, why? So a very important slide, like you can wait until these slides will be available on the official website, or you can get this by the end of today. So your choice. It's my website. You can get all the videos that I do, and I appreciate if you will be, liking those. But apparently these days, like YouTube will only appreciate if you watch until the end. So that's one of the important slides. Slides, code, examples, video will be there. Now, let's start talking about what are our options. Now, we as a Java developers, okay, let me, I'm saying we. I am a Java developer, but what about you? How many of you are actually using Java or JVM language? Kotlin, Scala, God forbid. Yeah, no Scala developers. In Sandon left, so no Scala developers left. And in Java, as many of the Java developers in JVM, we have a very fantastic piece of technology. It's called Java serialization. It's great, isn't it? It's amazing, right? So that's why we have I don't know, like 20 plus different serialization formats that are available in Java and other languages, because we have a out-of-the-box serialization so good, which is not. Now, the problem with Java serialization, it will rely very much on how the JVM works. In order to get your data from JVM, you need to turn it into a set of bytes. And Kafka really doesn't care what you're going to put in there. So Kafka really takes its bytes that it will receive over the socket and store these bytes in a disk. And only your application, your producer or consumer, will care what to do with those bytes. And in order to get this information from these bytes, you need to have this class available in class path in order to restore this. We're going to focus in about 3, but actually there is much more different serialization formats that actually don't require you to kind of heavily rely on Java. So the frameworks available across different languages. We're going to focus today on Avro, Protobuf, and JSON. Probably we should start with the order of JSON, because this is probably the first thing that people have in mind when they start thinking about, okay, what kind of message format we're going to be sending back and forth. So let's use JSON. You know, we use JSON in microservices, in our REST services. That's fine. Probably we can also use JSON in this context. So the problem when we are sharing stuff across different teams is usually how we can deliver the information about the data, so metadata. And in Java, we would just need to ship the jars that will have our classes, so this thing would be deserialized. So with the Schema Registry, that basically the focal point of our conversation, that's our Babel Fish for today's conversation. Schema Registry is a REST endpoint. It's a REST web service that allows you to store schemas, retrieve schemas. So when you're reading the schema, when you're reading something from your Kafka, you will be also reading data from Schema Registry. And after that, your application will figure out, okay, so it looks like a schema for this, and we will slap things together. So we're going to go with what we like to call these days is a data contract. So it's not only schema that defines our message, but actually defines the protocol that our services will be talking about. And Avro has human readable description that can be published and saved in the Schema Registry thingy. And what you can do, also you can, because it's a plain text, you can also make people reason about. So you can store it in version control. You can have a PRs and approval process on top of this. So you can have an idea about how the system will be communicating. And very interesting point that also how these changes that we apply in the schema will reflect on the messages that are already in Kafka and how the messages that will be published with the new schema. So usually we need to talk and think about the compatibility layer. So as I mentioned, Schema Registry is a REST application, runs on top of Kafka. It uses Kafka topics as a storage for storing the schemas. But when it starts, it's kind of like materialize those information in memory. So you using REST API in order to register schema. This REST API also exposed in the frameworks. For example, some of the client SDKs, say there would be Avro producer that will be taking data and turn it into the Avro format that will write bytes in the Kafka and write the schema into Schema Registry. And this framework also will take care of like a registering schema. But also you can do this manually. You can always put this through the process of your CI/CD pipeline. So, you go in from or GitOps, you go in through the point where you kind of discussing the schemas, you approving the schemas, merging pull request, and after that, this new version of schema will be registered. And different versions of the schemas are supported. That's kind of like a whole point of having this ability with the different levels of compatibility. Now, this can be integrated with your CI/CD approach. Why I'm talking about this and why it's important? It's kind of funny. I just realized that I'm talking about day 2 concerns, and usually like CI/CD concerns and integration concerns, and it's what we call day 2. And I'm speaking at the day 2 of current. I think it's funny. I don't know. Like it's funny for me. So yeah, there's plugins available that you can integrate in your CI/CD pipeline. So, for example, there's a Gradle plugin that can, register schema in Schema Registry when you need. But essentially, it's not that difficult to integrate this because REST endpoint the Schema Registry provides. You can move this into the REST endpoint. Now, one of the problems, or the biggest problem that we might have in a situation where we're dealing with the data exchange across multiple applications, where there's multiple agents involved, like agents not from AI agents, but the different the parties that interested to be involved in this data exchange. What's going to happen with your data if you say updated schema? What's going to happen with your data if you remove fields or like deprecate some of the fields? And the cool thing is that the Avro is probably the most sophisticated and the most well-researched kind of sort of, and also implemented the different rules about compatibility. For example, now we are submitting the messages and we have 2 fields. We have like username and the first name and last name, 3 fields. And we want to do some changes. Say we want to extend user profile. But we know that there would be some old consumers that needs to still consume this data. So you might have a new producer that will be producing data in new format, but your old consumer will be using same schema because of the compatibility level that you will be configuring for those schemas. So your old consumers will be continue to reading the data, and they will not break because the new schema will be updated. When we easily adding new elements to the schema, it's kind of cool thing about Avro is you kind of can define different schemas for writing data and reading data. So that's kind of like you can have a evolved consumer that can read data that was written in the old format, but also you can have the data that will be written in new format, but your old producers, your old consumers need to read this. Also, you can making sure if you are not like removing the explicitly fields, and you will be able to preserve pretty good compatibility between your applications. In other problems that usually might happen in the systems, like we have a JSON there, when you change the name, or there would be different mismatch on how different fields would be. So there's the camel case, there's the snake case, there's underscores. So there's multiple ways how we can describe this data, and this also will affect how your data would be, the consumed or produced, what's the breaking changes or not. So that's why there's a different compatibility modes, and Avro supports this both. You can define on your schema if you want to see that the data that you change will be compatible with the future. So you do like forward compatible. Your consumers that will use old data will be backward compatible, and also kind of like within it both works. So it's going to be full compatibility mode. Now, in this case, it's a polyglot harmony. Before we go into harmony and enjoying the stuff, let's talk about demo. I have I think, is it visible? No, I don't think it's visible enough. A little bit bigger, right? How we looking? So there's a wall of text here. I will explain. So in this case, in this panel, I will be having my order service. Order service, it is a microservice that's written in Java, and this service will be receiving the messages for buying order. We do have another system that will be running our inventory service. Inventory service would be written in Python. So let me see, because it's started too soon, because I need to create those topics. Because topics will be created by analytics service for all services. Let's see. Make build. Let's build this first, because it looks like something is missing when I was cleaning up. So we're gonna have the order service. We submit the order. We're gonna check if we have enough the inventory in our inventory database, and we'll have like analytics service that will be running our the analytics. We're gonna see like a dashboard and stuff. So analytics API is running. And that's the error I want to see. Second time always creates the topic. Perfect. And now we do have inventory service. 3 services should be up and running. Now, the can you see this? Is it visible for everyone? So I'm using this, I don't know how many of you heard about this Visual Code extension for Visual Studio Code. It actually works with the open source Kafka. You don't need to use like a Confluent and stuff. So my Kafka cluster has some messages, and it's also my Schema Registry that doesn't have anything. So those orders, let's take a look on those orders. Let's start from beginning. Hopefully there would be no messages. So right now there's no messages because we just started. Now I want to submit with the phase 3 normal flow. So with the normal flow, we're gonna have a bunch of things. So we're gonna submit the order to order service, and it's gonna be JSON naturally. Inventory service will allocate some components that we need to be shipping to our customer. And after that, we're gonna have something like this that will be capturing our event. So we send this one order that will have order ID, user ID, amount, and order was created. So that's normal flow, and the message would look something like this. Again, using this inside the Visual Studio Code allows to see what is going on here. Now, disregard this. I'll talk about this in a second. Key, value, we have order ID, user ID, amount, status created, and the product. If I go to my inventory, I should have this, product 4, 5, 6. That's what I want to, order from it. So my inventory service will register that says it's reserved. So 3 services, they talk in JSON, everything is great. But, all of a sudden, someone decide to do, let's do a little bigger, with the phase 3. First of all, what's going to happen if we're going to poison this topic with Java serialization, Java serialized objects. So inventory service naturally couldn't handle it because it's a Java serialized service, and analytics service naturally couldn't handle this as well. So we see some errors here saying that for some reason just trying to different. Received message that appears to be Java serialized, cannot deserialized. Obviously, it's a smart service. It can figure out by looking at the message saying that, oh, looks like it's a Java serialized. So let's take a look on this Java serialized message and how it is actually look like. And yes, as a matter of fact, you can look into this topic and kind of sort of say that, yeah, looks like, weird. It's a Java serialized. So that's what we kind of sort of seen, at least. I hope if you ever use this with the Java service, this is how the people usually start. So people say, no problem, we're going to go with JSON. That's fine. But with JSON, you also have all sorts of problems. JSON doesn't have the way how you can enforce out of the box, how you can enforce the format compatibility. So I'm gonna go with the make if is 3. Say let's do JSON mismatch. So we're going to submit the JSON that would be incorrectly formatted, and Analytics API will not be able to read this because in this particular situation, in this world, we actually use order ID and order underscore ID, which is also happens. You never know without looking at the data, you don't know what kind of the agreement or notation you should use in this case. Or if you do stuff like where is it? Phase 3. Let's call it type inconsistency. So with type inconsistency, the amount would be serialized with something else. So analytics immediately respond, and our inventory service also will not be able to create order with the amount that was submitted in a not integer format. So that's the problems that might happen. Now, so I can do make registered schemas, scripts and register schemas. So what was going to happen in this particular moment? Say let's start with my schemas. No, let's start with my order service. We're going to go with order service, and this is going to be here, and we're going to take the schema that we're going to be using. So we took this JSON format and we turned this into in our schema. In our schema, we do have a name. We can define namespace. We even can include documentation. So when you publish this in some data catalog or data contract service, that this information would be used. If I would be using like a Confluent Schema Registry in the Confluent Cloud, this information would be used to describe the information. So in a Java world, we don't need to do much of the hustle in order to use this event. So we can use the plugins to read the schema and generate our Java pods. So for that matter, in my, where's my build? Generated orders. So it will generate this Java. I call it Pojo. It's not entirely Pojo because it will include some additional information. So this order event that I can use in my Java application has a builder, so I can build my this order event in a fluent fashion. But it actually extends this specific record base, which is the part of the Avro framework, and those the subclasses or the superclasses, they will include some additional information in order to serializer will the serialize Avro message in order to deserialize this message. Also, my order event will include information about schema, and that would be built in somewhere here. It should be somewhere here. It does a lot of things, so that's why you never need to modify this file. I don't see there should be. Yeah, so for example, yeah, that's what I was looking for. So it includes information about schema inside this Java class. So when the framework that will be deserializing, it actually will be invoking the method to extract this from this message. So now, from perspective of Schema Registry, I'm gonna go when I Schema Registry, I click refresh. And did I call register schemas? No, I didn't call it. So now, when I register schemas, I took the different versions of those schemas and I published them into Schema Registry. So in my here, when I will refresh, what is going to happen is here, not my schemas would be registered in Schema Registry, and now those schemas can be assigned to the topic. There's different ways how, there's convention basically that says that, this is message format and what kind of like a topic this schema will be assigned. So in this particular case, so orders topic, and for value for this message inside this topic, we're going to assign this schema. And the schema, you already saw this, it will look something like this. Oop. Yeah, this will look exactly like you saw with different formatting, but it doesn't matter. Each field includes some additional information. Now, let's try to run this with Avro format now. So if I run this with Avro test. So now my topic, if I refresh it, now it has schema. So now the messages that will be published in this topic will have this information about the schema that they will be processed. And now my systems, it's going to be using data format uses Avro. So the Visual Studio Code extension is smart enough in order to like recognize different formats here. So for example, the previous still is there, still available. So it will be depends on your application if your application can read JSON, can read Avro. So that's why recommendation is never put the messages with different formats on the same topic unless you know what you're doing. I kind of sort of know what I'm doing here. Another thing is that I want to point out, I think this is also very interesting approach that some of the frameworks are doing. It's also quite legitimate, and I'm getting questions about the schemas and stuff from people who don't want to kind of like use Schema Registry. So another approach would be include information about payload inside some of the metadata. So in this particular case, headers will be used in order to define a type that is available for this message. But this is solely implementation specific. Anyone using Spring Boot in the Spring Kafka? Something like that, or a few people. So this is very specific to Spring Boot. They come up with this idea that their JSON serializer, deserializer, will read this information about this type, and after that find the class when we will be deserializing. So it's very specific to Java, very specific to Java frameworks. It uses Jackson. It's a Java framework to deal with JSONs, and Jackson can do the magic by the deserializing data from JSON into Java object. It's another way to doing this. It's possible to implement something in the opposite side. Maybe you can do the same stuff in different languages, but it's still JSON. It's still the text that can include all these sorts of problems. So let me see if I can do I have an evolution maybe script and data evolution. So if I want to go and change the schema, so let's do evolve schemas. Now, when I call this evolve schema, I have two versions of the schema. Version 1 of schema and version 2, which is backward compatible, and add some optional fields that allows me to define them as a backward compatible. So if I go to Schema Registry again, quick refresh. Now, do have a bunch of, for my orders, I have 3 different versions of the schema. So let's take a look on this one. It's very difficult to operate on a very small screen of laptop that is also cramped into. So this is the top of the schema that we use, and this is the version, which version I entered. So it's a version 3. It's a top version of the orders. Let's see how the version 2 would be different. Has a string. We do have a different type because it was registered from Java, so we can have additional alias that specifies. It's more information for the plugin that will be generating Java classes from the schema, but this information is here. Now, and let's see if I do have any optional types that we can demonstrate here. 222 order amount. So we do have a status, amount, user ID, order ID, timestamp, and some additional metadata. And with here, order ID, user ID, amount, status. So we, in the new version of Schema, we remove certain fields, and the schemas still will be, the messages still will be readable. You can define, if you can, when you're reading this data, you can define like which version of the schema to use to deserialize this message. So hopefully, the Avro is not only an option available in Schema Registry. You can use protobuf. Protobuf also follows very similar route, but protobuf has its own kind of rules for doing the schema evaluation and adding fields and dealing with the with data evaluation or schema evaluation. And also, we do support schema, JSON schema. So you still can have the JSON-like objects, but they will not be kind of like a JSON string per se. They will be kind of like a binary JSON that has a JSON schema on top, and it will use the JSON schema to deserialize. So it is there's a few options available for you if you want to use Schema Registry. Personally, I think, like I said already, the Avro is more or less quite well researched and very well supported by community. We at Confluent rely a lot of things in Avro. And also interesting thing about this polyglot thing. So we use. Let me see if I can show you. That's the part of the demo that I showed this morning. And I'm using laptop that didn't blow up. So inside our system, inside Confluent Cloud system, we use Schema Registry intensively because there would be multiple different components that will be talking to each other. Say, for example, we have a Kafka connector that will reading data from external database, introspect the schema of this database, and turn it into our schema and publish into Schema Registry. So your Java application that will be reading this, or whatever the application that will need to read this data, they will able to read this schema from the Schema Registry. And my Fling job that will be running inside my Confluent Cloud, the Fling job will be able to infer information about the messages from the Schema Registry. So if I would take a look into topics and say user summary, user messages, and the Confluent Cloud has ability to infer, so it can take a look on the message and say, hey, looks like you're running something like funky here as a JSON. We actually can give you schema and you can store the schema inside. So that we call it a data contract. So, and in this particular case, this data contract is already like it for 4 iterations, 4 schemas. And in this particular case, I'm using JSON schema because it was the simplest thing to do. You can start with JSON schema, and after that, you can move to another components. For example, I took the messages that user was submitting. I'm storing this in the Kafka topic, and my JSON schema will be used. But the results that I will be sending to Fling job, or result I'm getting from the Fling job, go to LLM summaries. That might have a different data contract. In this particular case, it will use the Avro schema now as a why it says JSON schema, like it's supposed to be Avro. It's supposed to be Avro. I was under impression that is Avro. This is weird. This is interesting. And also there's a, am I in the right place? Yes, I'm in the right place. So the schema can be associated with multiple different topics. Again, this is kind of like something that you define with the topic name dash value or topic name dash key. What else? Yeah, I can see the backward compatibility for the schema when I will run this evolution. So in this case, we not only use this for microservice exchange, we also heavily rely on this internally while we're building the services for our managed service. Now, so schema governance. I think the schemas also needs to be treated the similar way if you ever had the chance to work in the groups where you develop like open API spec for some of the services, and you need to like change the services and you need to evolve this. It's the same thing for your event-driven microservice or for your data exchange. There should be processes around, how these schemas would be reviewed, how the changes will propagate, so different departments can use. Also, schemas can enforce some of the data. What's the opposite corruption? Data integrity. So if the application, say, will be submitting that is not compatible schema, we don't need to publish this message in Kafka topic. We can reject this. We're doing this with the server-side schema validation components, but also other ways how you can enforce the schema governance and how it can be implemented as part of your organization procedures, and also how it will be implemented as a part of your Kafka implementation. And the Schema Registry will be treated as also your core infrastructure. Like I said, if you have, you will see real benefits if you're not using Schema Registry today, especially when you try to migrate or using a lot of like CDC stuff. You're getting the schemas from your different tables that you're available through connectors, and how it would be cool because this information would be immediately propagated to other components to be used. So your schema that was inferred from your, say, database tables, this schema would be published in Schema Registry and will be available across multiple places. So with this, as always, have a nice day. My name is Viktor Gamov. I'm available for enhanced interrogation as long as my flight not leaving until tomorrow. So I'll be here. Thanks so much for coming for this. Slides, video, and code will be published on my website. As always, may force be with you.